right, the point of this video, if you're lucky enough to find it, is just to give you some hints on how to start solving some of these word problems, especially if they're frustrating you. So the first word problem says we have the teachers at Armstrong, and we're going to have a rectangular fence far, far away from the school. Maybe at Mrs. Kennedy's house. All right. So they have 1,600 feet of fencing. Sorry about that. It might not have heard me that well. What's the maximum area that they can make? Okay. So in this case, they have a rectangular fence, and it looks like this. All right. And so their two x's and their two y's would add up to 1,600. All right, and if you remember on your sheet, on hopefully your note sheet, the first step is solve this for y. So 2y would equal 1,600 minus 2x's, and y would equal 800 minus x. So in other words, this is really 800 minus x. This is really 800 minus x. All right, so then your maximization formula would be x times 800 minus x. Now I'm going to leave this one for you. Know that you're going to multiply through here. I'll even do this for you. 800 x squared, x minus x squared. And you're going to then find the inverse of that, or not the inverse, excuse me, I misspoke, the derivative. We're going to find the derivative of this equation, set it equal to 0, and then solve. Solve it for 0. That is then going to be your maximum, your maximum y, or your y that will give you maximum area. And then you're going to also have to find the, or x, excuse me, and you're going to have to find the y value, the other value, and then find the area. Okay, let me go on here. Let's look at like this profit problem. At the Armstrong basketball games, on average 500 people show up and they get charged $4 a piece. But they did some studies and they said, okay, if they increase the price $1, for every time they increase the price $1, 50 fewer people show up. But if they keep increasing it, you keep getting more money. So when you increase it by $1, you get $1 more. Okay, so how many increases should we have so we can maximize our profit? How many is too many, where it's just like, oh, you're actually hurting ourselves some money? So at first it's going to be good because you get more money, but then you're going to lose people. But yeah, okay, so you lose people. But this is really a true to form what you have to do sometimes for these type of problems. So we have amount. If you remember, I said one time as we look at the amount, and here our amount is our people. All right, so we usually have 500 people, but it's going to decrease by 50 for every time we have a cost change. So let's call it X for change, okay? So for the amount, that's our expression. Then we always have an expression that deals with our money. Well, right now we get $4 for every person. We want to increase that by $1 so many times, and we're using this the number of times. X is representing here the number of times to increase the cost by $1. All right, cost by $1. All right, so now your formula for profit. Your profit is always how many people we have here, so we get charging per person. So the number of people, the amount, times how much you charge for a person. All right, so right now at each game, all right, I always like to look at this. You don't have to do this part, but I kind of like it. Right now, we get 500 people, and we charge them each and we get $4 from each of them. All right, so 4 times 5, we get $2,000 a game. Could we increase that and make a better profit? Well, the next thing we have to do here is our FOIL. Okay, so let me go through here, and I'm going to FOIL this. It's going to be here it's going to be 500 times 4 is 2,000. 500 times 1x is 500x. Negative 50 times 4 is negative 200x. And then negative 50x times positive 1x is negative 50x squared. So when I get my formula here, I get my formula of 2,000 plus, oh, one of these should be plus. Where did I go wrong? This should be, no. Sorry, guys. This one is plus, this one is minus, so this is plus 300x. minus 50x squared. All right, that's my profit equation. You take the first derivative of your profit equation. In this case, it's going to be 300 minus 100x. You set that equal to 0, okay? Setting that equal to 0 would mean that 300 equals 100x, and therefore my x would equal 3. So in other words, we should change it or increase it 3 times, each time increasing it by $1. So we suggest, all right, an increase of $3. All right, so new cost is $7 per person. We say that our new profit would give us, remember our profit formula here? Now we're going to put this, have it be 3 times we've increased it. 2,000 plus 300 times, 3 times we're increasing it, minus 50 times 3 squared. So our at $7 a piece, our profit then would be $2,450, which is a $450 increase. Now, know that this didn't have to happen. This was just me going, wonder what it would be. What I would really be looking at is that our new cost would be $7, or you could say here we suggest an increase of $3 a piece. Okay, so let's look at our next problem. Now our next problem, if you remember these, they look difficult, but they're not. Here is your maximization equation. You're just going to start by taking the derivative of your h. In fact, I'm going to let you do that one on your own. Let's look at these. These can be a little tougher. Find two numbers whose difference is 8 and whose product is a minimum. So we have our first number and our second number. Whoops. Now here, I don't think it matters which one I consider x. All right, it just doesn't matter. So if one is x, in fact, this is almost one where we can make one x, one y to begin with and say, okay, x, the difference between the two is 8. So then my y, I can say x minus 8 really is y. My y is really x minus 8. So the second number is really the first number, take away 8. Because the difference between these two, x minus 8, is going to be 8. And what we want to maximize or minimize is the product. That's what we're going to take as our maximization equation. So our function that we're going to maximize is the product of these two. Now I know that the hardest part is coming up with this, okay? And it really just takes some kind of logical thinking and some practice to really kind of get good at this. Sometimes it does help to just write it out in x in terms of x's and y's and then solve one for the y, and that's what's going to be your second number. I think that's a really good strategy right here. So now we're back to here where we have to do distributive property to figure out what this function is. It's x squared minus 8x. Our process now is we take the first derivative, so I'm going to find f prime, and that would be 2x minus 8. I set that first derivative equal to 0, and I'm solving it at this point, and then our x is 4. In other words, my first number is 4. The second number has to be, the difference between it is 8. So it's either 4 ahead of it or 4 below it. Well, it's going to be, or excuse me, 8 ahead of it or 8 below it, sorry. Our second number here would be 4 minus 8 or negative 4. Now they never told me that I couldn't go negative. So my first number was 4, my second number is negative 4. So the two numbers were 4 and negative 4. That is my answer. Okay? Let's see what else we have. This one I want to be careful on the picture because we have a rectangular fence, but then there's a fence down the middle. And it's parallel to the two ends. In other words, we have 3 x's here, and then this represents a y, and this kind of represents our y to begin with, okay? So what we know is 3 of our x's plus 2 of our y's equal all that fencing, and we have 900 amount units. So then 2y would equal 900 minus 3x, and y alone would equal 450 minus 1.5x. So in other words, excuse me, I've got the hiccups a little bit here. This is not great timing. In other words, this would be 450 minus 1.5x right there, okay? As would be the y on the top. That would be the same value here. That would be the 450 minus 1.5x. Ah, that looks terrible. Okay, so our area formula here would be just the area of the whole thing. So again, it's the dimensions. It's this dimension here times this dimension here. So it's x times 450 minus 1.5x. And then our formula would be 450x minus 1.5x squared. Our formula process right now would be to find the first derivative, set it equal to 0, and that's going to be your x. And then your area in the end, you're going to just use this formula again. Once you find out what x is, this formula right here, you're going to plug that back in. Okay? Let's see if I can help you on some other ones. Now here we have a bus passenger, and it has 200 people, so we're going to have one with people, all right, and another one with money. So we're going to have two expressions, people and money. The people, say we have 2,000 people, all right, and then we get 20 cents per passenger. They're thinking about a change, and every time that they're changing, every time that they increase it by 5 cents, so we're going to call this a 5 cents increase, they lose 200 passengers, but this is 200 every time they change. So they're probably going to change it more than 5 cents. It might be go 5 and then 10 and then 15, but they're really going to want to see what are they going to gain or lose in the end. And then profit is just going to equal those two equations multiplied by each other. You're going to multiply them out. You're going to take the derivative of that. Okay? I'm going to do let's look at that one. Let's look at 7. Another rectangular fence. I'm just going to really quickly make sure for this rectangular fence, again, we have a line down the middle. So here we have an x, an x, an x, and a y. So when you're maximizing, it's 3x plus y equals that 3,300 feet. So then y would equal our 3,300, minus 3x. Okay? So that's what this would be, 3,300 minus 3x. And we can go from there. Let's look at 9. 9 is, or 8, and then we'll go to 9. 8 is, there's a first number and our second number. So let's see if we can identify our first number and our second number. All right, I think that's where it gets the hardest. Two numbers have a sum of 9, and then their product of the second and the square of the first, that is the maximum. So ooh, this is getting a little bit confusing. One of them is going to be x. They have a sum of 9. So at first, if we call them x and y, and we know that we're going to replace the y, x plus y equals 9, the sum of 9. Well, then y would equal 9 minus x. So this is a good way to know, oh, okay, how do I write them both in terms of x? I just would replace that with 9 minus x. So now we have our first and our second. So now let's read the second part of the statement. The product of the second and the square of the first. Well, the square of the first would be that, x squared. The product of the second means times. So times the second, 9 minus x. This is our maximization equation right here. This is what we're trying to maximize. And I think it's going to help me if I think of it more this way. If I put the x squared first, and put then 9 minus x. So if I multiplied out, kind of did the distributive property here, I would have 9x squared minus x to the third. Okay? So when I take the first derivative of that one, I got 18x minus 3x squared. Ooh, now I'm supposed to set that equal to 0 and solve it, but I know enough to know I'm going to get two solutions to this. Well, the first thing I would do is I divide everything by 3. Okay. Dividing everything by 3, I get that we have 6x minus x squared equals 0. And if I factored out an x here at this point, I'd get 6 minus x here, and this is equal to 0. So in this case, x equals 0. In this case, x would equal 6.